So, Armani, what we were wondering what would go here if we wanted to get this as a result, basically. So, what did you get?
2x squared.
2x squared.
X. And 3, negative 3.
Okay, good. Okay, so this is basically what we call factoring. Okay, it's the opposite of multiplication. So the little story I told you was this was Jedrick's answer that he got by multiplying. So you guys need to unmultiply it in a sense. So what's the opposite of multiplication? It is division. So basically, if you want to find out what goes here, you would just divide this number by this. 4 goes into 8 twice. And also we have 3 x's here, right? So if we take an x out, we'll only have 2 left. And so you do that with each one. You would divide this by 4x, and you would get this. You would divide this by 4x, and you would get this. So that's what we call factoring. Okay, when you unmultiply something, it's called factoring. And whenever you unmultiply things, when you factor them, I think I'll probably explain this a little more on the next slide, but the pieces that are being multiplied, like this and this, these are called factors. So when you unmultiply something, the two results that you get are called factors. Okay? So we're going to be factoring for the next 3 days. So here we go. Factoring is the process of unmultiplying something. So if you have this, you would break it apart into what we had earlier. I guess we'll fill in those blanks again. What was that? It was 2x squared minus x minus 3, right? And then, in other words, it's where we break a polynomial up into 2 parts, and each of those parts are what we call factors. Factors. Okay? So this is a factor, and this is a factor. All right, now we're going to spend, like I said, 3 days on this, and that's because there's a variety of factoring methods that we kind of need to review. And I'll say review because we've done this before in Algebra 1. We haven't done it this year in this class yet. But there are 4 methods that we're going to talk about. The GCF method, the difference of squares method, the box method, and the grouping method. Okay, we're going to spend today on these 2. Those, in my opinion, these are the least challenging ones. This guy, in my opinion, is the hardest, and we're going to spend a whole day on just that one alone. So that's tomorrow. So be here and don't miss that day. And then this guy will get some attention on the last day. So let's talk about the first method, the GCF method. GCF stands for greatest common factor. Okay, so greatest means biggest. Common means something they have in common. Factor means whatever you get by unmultiplying it. So the biggest thing that you can take out or unmultiply is what we would call the greatest common factor. Okay, with this method, we divide out the greatest common factor. It's kind of like undistributing. So that's how I presented the problem to you guys earlier today when I gave you that problem in the very beginning. In order to get from here to here, you would be distributing, right? Well, what we're doing is we are undistributing whenever you take out a GCF. So when factoring, we should always start with this method if possible. So like I said, we're going to learn 4 factoring methods. Sometimes you could do more than one factoring method. And that'll be in our last day when we start doing multiple kinds of factoring methods at once. And when we have those kinds of situations, you always start with GCF first. GCF is always the first one to go. So we're going to begin here. So let's take a look at number 1. Now, let's see. So I'm just going to ask you guys, and if you get it wrong, it's okay. But this is just stuff that I'm kind of thinking you guys probably already have a background knowledge of. So I'm just going to ask you on the spot, so just be prepared. Now, whenever you're doing these problems, you have two types of numbers here. Okay, you've got these big ones. Bonus point. What are the big ones called? Oh, I would love to give all of you points, but I can't. If I had a hand, I could give it to me. But you're right. They're called coefficients. And the little numbers up here, those are exponents. So you have two different types of numbers, and the way that we handle them are going to be a little bit different for each one. All right, so first of all, let's start like this. We're going to have something on the outside, and that's what we're taking out. And what's going to result is two new things on the inside. So let's write that. That's just a setup, just to get us ready there. Now let's do the coefficients first. Aaliyah, the coefficients are 9 and 18. What's the biggest number you can divide out of both of those? 9 is. So let's take 9. Now, notice I asked for the biggest because we want the greatest common factor, right? So I can divide both of these by 9. What's 9 divided by 9?
1.
And what's 18 divided by 9?
2.
Okay, now after I do the coefficients, we'll look at the x's, okay? Now, this 9 has 4 x's to give. This one has 2 x's to give. Now, you can only take what they have in common, okay? So it wouldn't be fair for me to say, let's take out 4 x's. Why not? This guy can afford it, but this guy can't afford 4 x's. He doesn't have enough. So what is the most number of x's that I can take out? I can only take out 2. Now, let's put that there. Now, when you do this, when you take out this number, you're going to be subtracting this from what's there. So this guy had 4 x's. How many will he have now if I take 2 out?
2.
This guy had 2. If I take out 2 x's, how many will he have? He won't have any x's, right? He won't have any x's. So there's my answer, and I'm done. So divide out the coefficients and subtract out the exponents. Divide coefficients, subtract exponents. All right, let's go ahead and take a look at another one there. 12x cubed minus 9x squared plus 3x. I'm gonna make up a new one too in a minute. Okay. I'll write that down. So divide coefficients, subtract exponents. All right, so Cal, what are the coefficients on this problem? That's one of them. What else? 9. Good. 12, 9, and 3. All right. So for 12, 9, and 3, Sophia, what's the biggest thing I can divide out of all 3 of those coefficients? So I'm going to put a 3 here. So I'm going to divide all 3 of these coefficients by 3. So Jedrick, if I divide all 3 of these by 3, all 3 of these coefficients by 3, what will this new coefficient be? Next one? Good. Thank you, sir. All right. If something doesn't make sense and you want to stop me, let me know. All right. Next question I'm going to ask Bidal. Bidal, how many x's can I take out? You cannot take out 3 x's. You want to try again? You can only take out 1. And why is that?
Because there's only one because that one has 2 numbers.
So this one has 3. This one has 2. How many has this guy got?
1.
He only has 1. You can only take what they all have in common. So they all have at least 1x. So we could take out 1x. Now, let's see if I take 1x out, then Michelle How many x's will be here now? How about here? Here? Good. There's our answer. All right. Let's write down number 3. Oh, you already have it printed. You don't need to write it down. All right, now, I want you guys to write a little note here, okay? When the leading coefficient, that means the number in front. When the leading coefficient is negative, divide out a negative. Okay, so notice here that my leading coefficient, the coefficient that's in the very front, is negative. When that happens, we don't want to just take out what these two numbers have in common. We want to take out that number, but the negative version of that number. We don't like negatives in the front. It makes factoring harder in some cases where you have to do factoring multiple times. It's nicer to have that negative out of the way. Okay. So, for this one, we have negative 4x squared plus 8x. I'm going to do my little setup here. Something in front, and put blanks for these other numbers that are going to transform. Now, what goes into 4 and 8 is 4, right? But since we have a negative in the front, I want to take out a negative 4. Okay? So, Adriana, what will go here? What will the new coefficient be? It'll be 1, because negative 4 divided by negative 4 is 1, right? How about here, Adriana? Close. Negative 2. Because 8 divided by negative 4 is negative 2. All right? How many x's can I take out, you guys? Just one x. So this one will have an x left. This one won't have any x's. Now, I'm going to rewrite this a little bit. First of all, do you really need a 1 in the front? No. Second of all, if you're adding a negative, that's the same thing as subtracting. So this is what the answer would look like on a multiple choice test. But, yeah. All right. I have one more really weird situation that I want to share with you. I should have put it up here and I didn't. But we'll add it in there. Number 4. So let's add a number 4, shall we? 2x squared plus x. Not heck. We'll make it negative also. Why not? Let's do that one. Negative 2x squared plus x. A couple of interesting things are going to happen there. All right, so we're going to take something out. There's going to be something left here, something left here. All right, so let me ask Adrian, what are my coefficients on this problem? Negative 2, and what else? 1. So they don't have it written there, but we could put it there. And so, Kevin, what's the biggest thing that divides into 2 and 1? I'll give you a hint. It's kind of like a trick question. What's the biggest thing that can divide into both 2 and 1? It's just 1. That's it. In other words, they don't have anything in common other than 1. That means they're prime to each other. They're relatively prime. So all we could do is take out a 1. But let's see if maybe Kimaya can tell us. We've got to take something else out, Kimaya, with the coefficient that we talked about a little bit earlier. What else do I need to do when I take out the 1? You got a hard question. Give me your best shot. Okay. Does somebody know what else I still need to take out? We do need to do an x. I'll get to that in a minute, but was that Amaya? There's a negative in the front, isn't there? So we need to take out a negative one. Okay, remember, we don't like negatives in the front. So let's do our division here. Edwin, what's my new coefficient going to be here?
2x.
Well, I'm just the coefficient for now, but yeah, 2. Negative 2 divided by negative 1 is positive 2. And then, Alondra, what's this coefficient going to be? Close. Negative 1, because 1 divided by negative 1 is negative 1. And then, as it was mentioned earlier, we can also take out a x, right? You guys see how they have at least an x? And there's nothing here. So, yeah. There you go. So, I don't know, she said there's nothing there. What, right? Or did I say that? What did you mean by there's nothing there? Because we're a little confused by that. Somebody said that. I don't know.
Like there's no X.
Well, yeah, I mean, it makes sense to x.
Okay. So you're talking about this spot here? So yeah, there is an x there, so we could take an x out. And so we're left with that. I guess that's what they meant. So here's a couple for you guys. Show me what you got. Another note paper here. It's okay. That was my original policy, but I kind of lacked stuff on that little bit. That's a big problem. So how'd it go? You guys? You guys? So like this one, for instance, we're going to take out
No, I mean like
it's going to change. So I would encourage you to try these again. And then you try to do all three of those because then we'll check them out. Yes.
Mr. Bailey?
Just say. Yes, right. That would be the coefficient you take out.
I don't care.
No, sorry, I don't bring the charger over.
So we divide the coefficient,
I don't charge it. I really don't use it.
Right, I was gonna say, are you just like not on the nuts where it doesn't die by
Yeah,
the
no,
day?
I don't. I'm teaching all day. I don't have time. And sometimes during quizzes, I'll use it to grade homework.
how would I do that?
Good, and just don't forget that X there is going to square on it. So 5x squared on the outside. Yeah, so how many X's can you take out? So the first one has 5 X's, the middle one has 3, and the last one's supposed to have 2 X's on it. It's square there. But how many X's can you take out? It has to be something they can all get. You can take out 2 because they all have at least 2. Okay. take out.
we just subtract
That's
this
right.
Uh-huh.
So 5 minus 2 is just 2. 2 minus 2 is like 0. So you really could just take out 2.
Yeah, you're subtracting 2 from the exponents and then put that x squared on the outside.
So they all have x squared.
They all have at least 2 x's in the end. Oh. No, that's what you took out. Now this one, you add 5, you take 2 away from the well, if you take 2 away from 3, what do you get? This guy is so it's not wrong.
Yeah.
You want to take out the greatest number backwards. You want to take out. Now I know if you did a negative, but there's no need to take a negative because our front number is not negative here, so just a positive 5.
Everybody have no, please don't. Oh my God.
Just so I have some check answers with it.
Mm-hmm.
Yeah.
And then you're gonna divide 2 by.
Now this one up here, number 1, take out 2x. So you would have 5x squared.
Yes.
Yeah, so
Divide 2
number
by 3.
You break the
For the last one, it's only 1.
but other than that,
With the exponent,
I might give it back to her.
because 2 will go into all of them. Yeah, 2 will go into everything.
I like oh. Oh, there you go. You guys can catch with
You want one line? Thanks, Mom. Thank you, Mom.
we all work together.
I forgot to see how he got it. I think so.
Yeah.
Yeah.
Like, you did the process, right? So like you didn't take out 6 here. You take out 8.
Or
And I think you're saying that
divider.
you take out
8 from 16, then 8 from 8.
here, you take out x squared. So anything right there. So like here.
Oh, they probably took it up because she's mad and made her. But she was well, she did not contact her.
So on number 1, you need to take out 1 more.
And she decided to tell her like, if I can
On number 2,
and now watching TV. I so bad.
so you would start. You can quite take out and then Shakir, so I can get out of Lily's seat.
But it feels good.
You work with Kevin.
In Spanish, well, the F here
Work together. So this guy.
Oh my God.
Almost every one has this one, but you took how many X's did you take out?
Oh my God. I'll check my pencil back on my head.
This guy looks at me like that. I like what you put out here, but if you take an X out,
I tried to. Do you have tissue?
Up on the table there, I do. All right. I'm gonna call on people, put their answers up. So, or just tell me their answers. So, Shakir, what did you get for number 1?
Like I'm so serious.
2x to the what? Guys, can you all be quiet, please? All right. Thank you. All right. What I found interesting about this one is some of you guys knew you were supposed to take out 2 x's, and so you had the right things here, like 3 and 1 here, and then none on the end. But you didn't write square on the outside; you just put x. I found that interesting as I came around and noticed that. Some of you really didn't notice to take out 2 x's; you only took out 1. So do notice that we have 5 x's, 3 x's, and 2 x's. So we can take out, the most we can take out is 2. We can take out 2 x's. All right, let's go ahead and take a look at number 2. Number 2 is a little bit, less people struggle with that one, but let's see. Niana, what did your group get for that one? You gonna pass on me? All right. Miles, what did you get for that one? Miles. Oh, okay. Bridwell, what'd you get here? What'd you get here for number 2? Did I? How do you say it? Bridewell. Interesting. Okay.
It's 2x.
Uh-huh.
And then x to the second power.
Uh-huh.
Minus 4x.
Uh-huh.
Plus 1.
There we go. I'll have to remember that about the last name. That's interesting. All right. Denise, what did we get for the last one?
8x. 2x to the 6th power. Take away 1.
Okay. Any questions about that? Anything I can answer? Something that didn't make sense? Yeah.
It's just the exponent. It's a little bit confusing.
So basically, if I were to write it out in words, I would say the first thing you do is It's kind of hard to explain, but how many exponents can you take out? Now, I was kind of pausing there because I don't know how to answering that question is a little bit tricky, but I'll try and without making it like a really long paragraph.
So you can only take out one, right?
Where for which one? Yeah, very good. So you kind of know that already. Now on number 1, how many can we take out? Like up here, how many can we take out up here? 2. So basically, here's how you can tell how many you can take out. Look for the smallest one, 5, 3, 2. Smallest one's what you can take out. Here we got 7 and 1, so the most you could take out is 1. So ask yourself how many can you take out, and then you subtract it. So how many can you take out and then subtract?
So within the 2, we only took out 1 and 2, right?
Correct. So notice that I only took out x to the first power, and then we subtract that from all of these. So now 3 take away 1 is 2. 2 take away 1 is 1. 1 take away 1 is 0. Now technically you wouldn't be wrong if you wrote this, but I would say just don't put the x at all. By the way, does anybody know what x to the 0 power equals? Any number. Wow, who said that? I heard one over here.
That was me.
Don't lie to yourself.
That's really good memory, yeah. It's a weird thing, doesn't make sense, but a number raised to the 0 power equals 1. It's weird. We'll talk about it some other time. But this basically just equals 1. So what you have is 1 times 1, which is 1. So if you just don't even write it, you'll probably be good. So that's a lot of just extra blah blah, so you don't have to pay attention to that. But basically, to answer Leah's question, look how many you can take out. It's the smallest one. And then subtract it. Any other things I can clarify before we move on? All right. So I noticed that was a little bit more of a struggle than the multiplication for you guys, but it seems like you wrestled through. You got okay. I think the next part, in my opinion, is easier than this, but we'll see how you guys do with it. So the good news is I think it's going to be a little bit easier on the method too. But this is, remember, we're talking about 4 ways to unmultiply polynomials. This one's called the GCF method. We're moving in now to the second method, which is called the difference of squares method. I think it's my favorite one because it's really fast. And in my opinion, maybe not yours, but we'll see. It's really easy. So, difference of squares method. All right. So a difference of squares can be used if you have the difference of 2 squares. So in math, what does difference mean, you guys? It means subtraction. So you have a difference of 2 squares. 2 numbers that are perfect squares, like this. That's an x squared, that's an a squared. So this is a difference of squares. So if you ever see something like that, then you can apply this method. So, I guess we could put that there. So here's a general example. Now the thing, so go ahead and write that in there on your notes. That's the difference of 2 squares. Now, they're not going to always make it look like this. Look at something real quick. Here's how the difference of squares works. Ready? Underneath of it, I want you guys to put 2 sets of parentheses. And what we're going to do is we're going to split the x squared up evenly. What times what makes x squared? X. So you're going to put 1x here, 1x here. What times itself makes a squared? A. So you're going to put an a here, and you're going to put an a here. So basically you're just splitting them up. So split up the x's, split up the a's. What's that? Good question. All right. So one of them is plus, the other one is negative. And it doesn't matter which one is plus and negative. The order doesn't matter. Okay? So split up the first number, put it in front. Split up the second number, put it in front, or I'm sorry, in the back. Make one plus and make one minus. All right? So let me give you an example. We're going to do a few examples, but let me give you one here. X squared minus 9. You don't have to write this if you don't want to. We're going to do plenty of examples in a minute. But let's split up the x squared. We already did that. It's going to be what here and here? Both of these are x. Now what? Now 9. There's only, yeah, so what times itself makes 9? It's 3 and 3, right? 3, 3. Make one minus, make one plus, and you're good to go. That's the difference of squares method. Yeah. So now I want you guys to be careful, though. A sum of two squares does not factor. So if you ever see something like this, both of these are perfect squares. Like this is 3 squared, and this is x squared. But even though those are both perfect squares, you cannot do a difference of squares method on this because there's a plus in the middle. This does not factor. We call that a prime polynomial. Just like prime numbers are numbers that can't be factored. You can't break them down anymore, like 3. What times what makes 3? Well, nothing, just 3 and 1. That's not helpful. That's a prime number. Well, polynomials can be prime as well. If you can't factor them, we call them prime. And not every polynomial can be factored. Correct, correct. Now, I don't plan on trying to trick you with this, but for those of you guys who are kind of ready for a little higher thinking on this, this is a difference of squares. It just looks funky. It's in the wrong order. They decided to put the negative first and the positive second. Do you guys see if I rearrange it? Yeah. Now it looks right. So I could give you something funky like that. I don't plan on doing that, but I just want you to know. All right, so let's do some differences of squares. I think I already did number 1, so I guess that'll be pretty easy. X squared minus 9. All right, 2 sets of parentheses. We already know if we split up the x, we get x. We already know if we split up the 9, we get 3. We know one's plus and minus. I'll just kind of go through that one quickly because I already did the problem. So. Yeah, me too. That's not big. Not too bad. It's not like the GCF. GCF is a little more tedious. Here we go. I shan't. So I would call number 1 like, you know, a really straightforward example. The next ones I'm make you think a little bit, but maybe we'll see. All right, so let's begin. So we're going to have parentheses, parentheses. Now I'm going to use my cards, but if you don't know, it's okay. Just do your best. Okay. Leah, what multiplied by itself would give me 4x to the 4th power? In other words, if I split that up evenly. 2, I need more though. There's an x in there. 2. 2x to the 2nd will do it. Yeah. So 2x to the 2nd. 2 times 2 is 4, and 2 plus 2 is 4. So there's your split there. Lily, what multiplied by itself? It has to be itself. It can't just be any pair. It has to be identical. Well, what number times itself makes 25? 5. Make one plus, make one minus, and we're all done. All right, let's go ahead and take a look at number 3. One minus 16x squared. Parenthesis, parenthesis. Crystal. What's going to be my first number? No. 1. So what times itself makes 1? 1. So that one's just going to be 1. All right. Let's do the 16 next. So Alonzo, what goes here? I need a little more though. Yeah. I know we all want to forget about our x, but hey. No. All right. 1's plus, 1's minus.
Oh my goodness.
What did you say, Leah? No, no. 8, yeah, so 8 times 8 is 64. We want what times itself makes that. So there's that. All right, number 4. 4x squared plus 49. Now, for this one, I'm just going to tell Amaya that I'm trying to trick you. Can you tell me why I'm trying to trick you? It is prime because this is a sum of squares. This does not factor. So you could just say prime, or you could say does not factor. Or you could say both. Because this is a sum of squares, not a difference of squares. You can't apply this method to it. Okay? So there's some for you guys. Show me what you got. And that will do it for the day for us. Uh-huh. Oh, yeah. So it won't work. So what you can do to prove that it won't work is you should be able to work your way from here to get back to here. Try the box method and you'll find that it'll give you this. It'll give you something. It'll look similar, but it'll be a little bit different. So try multiplying and see what you get. Is that was the teacher. Of course. Oh, thank you. Yeah, no, I'm going to come check notes. So let me come around and peek at notes. You guys can just show me both sides of your notes. I'd appreciate it. 5 minus. No, you split it up in half. So it's 3. X cubed to the 3rd power. Search for the sign. All right. I don't know how to explain it. So 9x squared. So square root of 9 is 3. And then square root of x squared is x. Yeah. And then all you do is add. I'll put the answers on the board in case you guys want to see them. I did. You're good. Thank you. All right, guys, there you go.